Alright, time for the solutions for the recursive and explicit functions assignments. It's kind of just to review a mix of writing the recursive functions, writing the explicit functions, and getting the 15 term in the sequence. So before you can write your explicit or recursive function, you need to figure out what the pattern is on your sequence, and this one is adding 3 every time. And so this one is going to be an arithmetic sequence, which means we have a common difference, and since it's adding 3 every time, that difference is 3. Our initial value, which is the first term in the sequence, is 40. If you want the recursive function, this one's arithmetic, so the pattern for recursive function is a sub n equals a sub n minus 1 plus your initial value, plus your common difference. And you also have to say where to start, so a sub 1 is 40. Ta-da! That's a 40. If you want the explicit function, you just write a sub n, and you put your common difference in front of n minus 1, and then add your initial value, and there's your explicit function. If you want to get a sub 15, you take 15 and you put it in the explicit function like so. Wherever you see an n, put 15. And if you compute that, you're going to get 82. So a sub 15 is 82. And that brings us to 2. This has a pattern of timesing by -3. So this one is geometric. It has a common ratio of -3. And the initial value is just the first term in the sequence, which is -4. If you want a recursive function for a geometric sequence, you write it like so. A sub n is equal to your common ratio times a sub n minus 1. And you have to say where to start, so a sub 1 is -4. If you want the explicit function, you write a sub n equals your initial value, -4, times your common ratio, -3, to the n minus 1 power. And that one's good to go. If you want to get the 15th term of your sequence, you just plug 15 into your explicit function. Make sure you put in the explicit one. Otherwise, getting the recursive one might take quite a while, because you have to backtrack quite a bit. Anyway, when you compute that one, you're going to get, alright, if you compute that, you're going to get -19,131,876. And that's a fairly large number, but that's kind of what you expect when you times by -3 14 times. Moving on to number 3, this one has a rather simple pattern of just adding 6 every time. And since it's adding every time, it's arithmetic, it has a common difference of 6. The initial value is the first term in the sequence, which is 4. If you want the recursive function, you write a sub n equals a sub n minus 1 plus 6. And then you should say what the initial value is. A sub 1 is that initial value of 4. If you want the explicit function, you're just going to follow the same form that we did on number 1. A sub n is your common difference, which is 6, times n minus 1, and then you add your initial value of 4. And there's your entire explicit function. If you want to get a sub 15, you're going to plug that into your explicit function. So you do 15 minus 1, plus 4 on the end. Then you just have to do the 6 times 15 minus 1, which is 14, and then add the 4, and that's going to give you 88. So that's what a sub 15 is. On number 4 here, this one is also arithmetic because you're just subtracting 5 each time. Arithmetic. Since you're subtracting 5 each time, your common difference is -5. The initial value is the first term in the sequence, which is -29. The recursive function for all arithmetic sequences is just a sub n equals a sub n minus 1, and then you add your common difference, or which in this case adding -5 is the same thing as subtracting 5, and then you say where to start your sequence, which is -29, just like that. The explicit function is going to be a sub n equals, then you write your common difference in front of n minus 1. Close that up, and then add your initial value of negative 29. Or I guess I could just put subtract 29, which is okay. If you want to get a sub 15, you just take 15 and put it into your explicit function, right where you see the n, and then you compute that. Let's see, 15 minus 1 is 14. If you times that by negative 5, you'll get negative 70. And if you subtract 29 more, you're going to get 99. So a sub 15 is going to be 99. Alright, moving on to the next one. With this sequence, we just have this pattern of timesing by 5 each time, all the way down. So this one's geometric because we're times by the same thing every time we get a common ratio of 5. The initial value is just the first term in the sequence, which is 1. If you want your recursive function, you write a sub n equals, remember this is geometric, so slightly different than the arithmetic one. You're going to do 5 times a sub n. That says every term is equal to 5 times the previous one. And then you should say where to start. I'm going to start at 1. So a sub 1 is 1. The explicit function for geometric sequences is awfully similar. Your initial value is just going to be 1, and then you times by 5 to the n minus 1 power. Really, that 1 doesn't do anything. You can forego having that. Just skip that if you want. Oops. Anyway, but I'll keep it there now. If you want a sub 15, you're going to take 15 and plug it into your function for n. So you do 5 to the 15 minus 1 power, and that's going to be a really large number. Let me do that real quick. Alright, well, it's over 6 billion. It's this number here. And that's why we use calculators, because doing that by hand would have been really, really annoying. Anyway, moving on to number 6. What you're doing this one, so even though it's in pictures, what you're really doing is getting the amount of dots, so 1, 5, 9, etc. And since this one is just adding 4 dots each time, this one is arithmetic, and your common difference is 4. Your initial value is just the first number, which is 1. Recursive function, always the same for, well, it's always the same form, basically. Every number is the previous one, and in this case you add 4 to the previous one to get the last one, and you need to say where to start, so a sub 1 is 1. For the explicit function for arithmetic sequences, you're going to have 4, common difference in front of n minus 1, and then you're adding your initial value. If you want a sub 15, you just take 15 and put it in your function for n, and compute that. Let's see, 4 times 14 plus 1, you're going to get 57. So a sub 15 is 57. On the next one here, this one starts at 1, then we get 3, and then 5. So this one's just adding 2 each time, which makes it arithmetic. We're going to have a common difference of adding 2, or just 2, because it's just a number. The initial value is the first number in the sequence, which is just 1. The recursive function is going to be the same as this, except you're going to put a 2 instead of a 4 there. It's an a plus 2. Make sure you list where it starts. On the explicit function, a sub n is, well, make sure you put your common difference in front of n minus 1. And then you'll add your initial value, which is great. If you want to get a sub 15, you take that function and you put 15 in for n, and then you compute it out, which is going to be, see, 2 times 14 is 28, add 1, going to give you 29. 29 there. And then that's going to bring us to number 8. This one is not arithmetic, it is timesing by 4 every time, so it is geometric, which means we have a common difference of that number 4 that we're multiplying by each time. The initial value is the first term in the sequence, which is 2. The recursive function for geometric sequences starts with this, and you need to tell what number you need to multiply by every time. That's 4. And you also need to say where it starts, so the first term in the sequence is 2. The explicit function for all geometric sequences starts with a sub n is initial value times common ratio to the n minus 1 power, and that's it. To get a sub 15, you need to put 15 into your explicit function for n, and then compute it out, which will give you, which is in just slightly over 1 billion. So yeah, things get pretty big pretty quickly with geometric sequences. On number 9, this one starts at 45, and it's getting divided by 3 every time, so this one's geometric. It has a common ratio. If you're dividing by 3 every time, your common ratio is going to be 1 over the number, so 1/3. We started at 45. To write your recursive function, you can write a sub n equals your common ratio times a sub n minus 1. And then you need to say where to start, so start your function at 45. Start your sequence at 45. If you want the explicit function, you're going to have a sub n is initial value times your common ratio to the n minus 1 power. And if you want to get the 15th term of the sequence, you're just going to put 15 into your function for n. 15. And when you do that, you're going to get a 9.48, a bunch of stuff, and then e negative 6. Well, that just means it's 9.48 times 10 to the negative 6 power, which you could, if you convert it to a decimal, is going to be 0.0000009 if you were to round it. So that's what you're going to get for that one. Moving on to 10, this one is again back to our classic arithmetic sequence. It's subtracting 7 every time. So it has a common difference of -7. The initial value is the first term of the sequence, which is 40. The recursive function is a sub n equals common difference times a sub n minus 1. And then you need to say where to start, so a sub 1 is 40. The explicit function is going to be a sub n equals -7 times n minus 1 plus 40. And if you want to get a sub 15, you're just going to take a sub n, the explicit function, and put 15 in for your n value. And we can do that fairly quickly. It's going to give you -58. And moving on to 11, we have a pattern here of timesing by -2, which is going to make it geometric. Our common ratio is going to be -2. Initial value is the first number in the sequence. Your recursive function is going to be your common ratio in front of a sub n minus 1. And you need to say where to start, so a sub 1 is -3. The explicit function is going to be a sub n equals initial value times common ratio to the n minus 1 power. That's just right off your notes. If you want to get a sub 15, you plug 15 into your function for n, like so, and then you compute that. Okay, it's going to give you about 49,000 negative. And then finally 12, we have a pattern here of just subtracting 4 every time, which makes it arithmetic, with a common difference of -4. The initial value is just the first term in the sequence, which is -4. The recursive function is going to be a sub n equals a sub n minus 1 minus 4, because you're subtracting 4 every time, and you have to say where to start, so the a sub 1 is -4. The explicit function for arithmetic sequences is a sub n equals initial is common difference times n minus 1, and then plus your initial value of -4. If you want to get a sub 15, you take your explicit function and you put 15 in for n, and then you compute from there. And this one is going to give you -60, and this one's done.